Hello, hello, hello. I'm just physics lesson 6.1, impulse and momentum. Alright, so momentum. This is defined as inertia in motion. So anytime something has mass and velocity, we're going to have momentum. You need the combination of the two. So if you have two objects that are exactly the same, so 5 kilogram objects, one's at rest and one's at 4 meters per second, the one that is moving is going to have momentum. They're going to have a momentum that's equal to their mass times their velocity. Now, as far as formula-wise goes, we're going to use this nice little P for momentum. All right, so if we have momentum, we can also have a change in momentum. That's what delta P is. And what's happening is the only thing that can really change is our velocity, right? Because the mass isn't going to change. So that's our impulse. Some quick rundown of our formulas. The one that's going to be most helpful for you in my class is this one right here, where our force times our time equals our mass times our change in velocity. And if you break it down, it should kind of make sense. So force equals mass times acceleration. Remember, that's Newton's second law. Acceleration equals velocity final minus velocity initial over time. So if we take this part of the equation over here and substitute in for that A over there, our force equals our mass times our velocity final minus our velocity initial divided by time. Take this little stinker over here. And we get our force times mass times change in velocity. Not too shabby. Alright, so let's put this to work. Suppose you have a soccer ball, and the mass is 0.75 kilograms. The initial velocity equals 16 meters per second, going towards Roy. Roy kicks the ball back the way that it came from, so velocity final equals, I don't know, using a force, which is 180 newtons, and that should be going backwards, so that's negative, on the ball for a time of 15 seconds, so the time equals 0.15. Use concepts of impulse and momentum to find the ball's final velocity. Alright, so let's plug in some of our info here. So our force, negative 180, multiplied by our time, 0.15, should equal our mass, 0.75, times our change in velocity, which is velocity final, minus 16. And that should give you negative 20 meters per second. Okay, so on this next page here, I ask you to do it both ways. So suppose you have a 40-kilogram shopping cart. It's rolling towards your car at 18 meters per second. Perhaps you're in Kroger's parking lot in the village, which has a parking lot the size of one parking space. Anyways, you have to do so in 3 seconds, then figure out the force required to do it. So there's two ways that you can do it. So you can use our new equation here, which is going to be force times time equals mass times delta V, where our time is 3 seconds. Our mass is 40. Our change in velocity, so our final, which is 0, minus our initial, which is 18, should be negative 18. And that should give you force of 240 newtons. Now if you do it the other way, you're going to have to break it up into steps. So our acceleration should equal our change in velocity, which is 0 minus 18, divided by 3. So our acceleration equals -6 times our mass, which is 40, and that should give us our force, which happens to be the exact same, -240. So either way works. This one will probably be more helpful as we move forward. All right. Next session, we're gonna learn about collisions. Watch it, watch it, watch it, watch it. Aww. Oh, there's another Mustang. I like Mustangs. Okay. I will catch you next time. Goodbye.